Okay, we're going to do partial fraction decomposition, case number 4, repeated quadratic factors. You see here I've got x, and that is a what? Distinct linear, because there's only one factor of it, and it's first degree. Now I've got x squared plus 1, and that has a negative discriminant. Okay, so you can verify that for yourself. This would only be factorable with plus or minus I, right? So it is called what? An irreducible quadratic. And the fact that there are two factors, it is repeated. Okay, now, our decomposition. This linear factor is going to produce one fraction, just a over x. Now, the x squared plus 1 to the second power is going to contribute two fractions. And remember that each of those fractions will have a first degree numerator. Let's write it out. The first fraction has a denominator of x squared plus 1 to the first power, and the numerator is linear, so it is a first degree polynomial, bx plus c. Okay, first degree, I don't have to write it. I don't have to write the 1. And then we're going to increase that power on that denominator by 1. So it goes from a 1 to a 2. Okay? And then again, the numerator is linear. So it's a dx plus e. Okay, now, if there was a power of 3, okay, we'd be very unhappy, but there'd be a what? Another fraction, and it would be x squared plus 1 to the third power. Okay, and then again, the numerator would be linear. It might be a what? Fx plus g. Okay? All right, so now we need to find our A, B, C, D, and E. That's a good refresher of the alphabet. Okay, so let me go ahead and erase this and make a little room. We're going to now multiply both sides of the equation by this denominator. Okay, same story as all the other cases we've done. And so now I have x times x squared plus 1 squared. Okay, but now I have to do that to this right side as well. So I've got x times x squared plus 1 squared. Okay, now that in red will be distributed to each fraction there in black. Okay, and what will that give us? Again, these will cancel, so you're left with 1 minus x plus 2x squared minus x cubed. These x's will cancel, and I'm going to be left with a times what? That x squared plus 1 to the second power. And then multiplying here, this one factor of x squared plus 1 will cancel with one of the factors, leaving us with bx plus c times x squared plus 1. And then lastly, we've got this fraction in black multiplied by this in red. Those x squared plus 1 squareds will cancel. And I'm left with dx plus e times x. Okay? Whew, what a mess. Okay, now we're going to use a combination of the convenience method and the method of undetermined coefficients. So anticipating that, I'm going to multiply the right side out, and I'm going to end up with what? A times, well, here, let me do this. I know that if I were to multiply this out with FOIL, I'd end up with an x to the 4th plus 2x squared plus 1. But then each of those terms has to be multiplied with an a. So it would give me ax to the 4th plus 2ax squared plus a. Yikes. Here you'd have to distribute here, so you end up with an x cubed plus x, but then that would be foiled with bx plus c. So that would give us a fourth degree term, b x to the fourth, c x cubed, and then I'd have also a b x squared and a cx. Okay? And then lastly, I'd have here a dx squared plus an ex. Okay? All right. Now, if I were to plug in an x value of 0, okay, I'm going to use the convenience method here. That 0 would make all of this go away, and it would make this go away, and you'd be left with this term here. Okay? So that would leave you with just a times 1, right? Because it would be 0 plus 1 squared. And then on the right-hand side, plugging in 0 would make all those terms go away. So you've got one freebie. Okay, not much. All right, now we already know what A is, and I know that I've got these fourth degree terms here. A and this B would now have to add up to what? There are no fourth degree terms on the left. So that means that I can form this equation in red. This 0 would really come from adding A plus B. Okay? Which tells me already that B is going to be -1. Okay? So now, let's pick a different color. What do we got here? All right, so we've got a third degree term, which is just this c x to the third. That would have to match up with just one term on the left. So that tells me that this -1 has to equal c. That wasn't too bad. Okay? So we've got 3 of our, 5 variables already. And I need a different color. So now let's jump down to the second degree terms. We've got a 2a x squared. That would combine with this bx squared and that dx squared. And they would then have to add up to this right here. Okay? So we've got the purple boxes give us or blue I should say, give us this blue equation. So 2 on the left has to come from what? 2a plus this b plus d. But we already know what a and b are. Okay? So a is what? 1, right? Remember a is 1. So it gives me 2 now. B is -1 plus d. So now that tells us that d is 1. Right? All right, we're just about done. Now, why don't I just pick back to black? Back in black. You get it? Back in black? Okay, anyway, the x terms on the right, this cx and that ex have to add up to this 1x on the left. Okay, so that gives me what? -1 is equal to c plus e. Okay. But we already know that c is -1, which tells me that if I add 1 to both sides, e is 0. Okay, so the variable e is 0. It's going to drop off. Okay, so let me have to erase here. In conclusion now, our original fraction here, which was this 1 minus x plus 2x squared minus x cubed, all divided by x, times x squared plus 1 squared. Now decomposes into a over x, but we know that a is 1, so it's 1 over x. B is negative 1, so we've got negative 1 times x, plus c, but c is negative 1, all over x squared plus 1. Okay, then I've got a dx, but where's d? D is also 1, so I've got a d, and the e was 0, and there is our partial fraction decomposition. Okay, so the original fraction that we were given, it broke down or decomposed into those 3 fractions there. Okay, and again, for you calculus students who might be watching this video, how would you integrate this? Okay, so if you're going to integrate this on the left, you have to integrate each part on the right. That would be what? Tell me. The integral of that would be what? Involving natural logs, right? This, you have to break it up into 2 fractions, right? So this could be then split into a negative x over x squared plus 1. So that could be a simple u substitution, but then it would be a minus 1 over x squared plus 1, right? And that would be an inverse tangent. And then here, how would you integrate this? Would you go through the torture of trigonometric substitution? Absolutely not. You would just make a simple u substitution, right? All right, I hope that helps. Do your homework.